students, in this lecture I am going to discuss about risk profile and expected value of sample information, finally computing branch probabilities with the help of Bayes theorem. So, the agenda for this lecture is risk profile, expected value of sample information and computing the branch probabilities with the Bayes theorem. First, we will discuss about what is risk profile. The right hand side, this was our final solution for our decision tree problem by using backward strategy approach. So, for this solution we have to provide the risk profile. So, for the risk profile we know that to draw the risk profile we need to know the probability and the payoff. For example, here there is a 20 is one payoff is there. Now, we have to find out what is the probability for that. So, the probability of following that the sequence of branches can be found by multiplying the probabilities for the branches from the chance node in the sequence. So, for example, the payoff is 20. So, what is the sequence? Here there is one sequence and here there is another sequence. So, the probability of the 20 million payoff is multiplication of 0.77 and 0.94, we are getting 0.72. Similarly, the probabilities for each of the other payoff are obtained by multiplying the probabilities for the branches from the chance nodes leading to the payoff. By doing so, we find the probability of minus $9 million payoff, for example, this one. Okay, how to get the probability for this payoff? So, we have to multiply this 0.77, this one, then 0.06, okay, this one. So, we got 0.05. The probability of 14 million payoff, for here we have to multiply this 0.23 and this 0.35. So, we are getting 0.08 and the probability of $5 million payoff is again 0.23 multiplied by this 0.65. So, the probability is 0.15. So, this says the payoff and corresponding probability. So, when you plot this is called risk profile. What is that? There is a minus 9 and 0.05. Similarly, 5.15, 14 here, 14 0.08, 20 0.72. Now, we can see the comparison of the risk profile. What is this comparison? The left side picture says the risk of making the decision without a sample, that is without a market research study. So, this one is the left hand side is without market research study. Okay. So, what is that payoff and corresponding probability? Minus 9, 0.2, 20, 0.8. So, here what I am going to find out? I am going to find out the variance. After that, I am going to find out the standard deviation. The standard deviation says that the risk. So, we know what is the formula for the variance. What is the formula for variance? Sigma of x minus mu whole square multiplied by p of x. So, here mu is this 14.2. How we got this 14.2? In Excel, we have to use sum product formula. So, we have to select minus 920 comma 0.218 0.8. So, we will be getting 14.2. Then there is nothing but minus 9 multiplied by 0.2 plus 20 multiplied by 0.8, you will be getting 14.2. So, first we will find the variance. Variance is x minus mu whole square, that is minus 9 minus 14 point. So, for example, I am writing minus 9 minus 14.2 whole square multiplied by 0.2 plus 20 minus 14.2 whole square multiplied by 0.8. So, that sum is your 134.56, that is the variance. So, this we can say variance. So, when you take the square root of that, we are getting the standard deviation. So, the risk of taking the decision without market research study is 11.6, but come to the right hand side. This is with market research study. So, we have the probability minus 9.05, 5 0.15, 14 0.08, 20 0.72. Here also first we have to find out the mean. So, this is your mean. Next we have to find out the variance. The same formula, what is that? X minus mu whole square p of x sigma. So, here x is minus 9 minus 15.82 whole square multiplied by 0.05 plus 5 minus 15.82 whole square multiplied by 0.15 plus 14 minus 15.82 whole square multiplied by 0.08 plus 20 minus 15.82 whole square multiplied by 0.72. When you sum it, you will getting this one variance 61.207. So, when you take the square root of that, we are getting 7.8. Now, you see the comparison. Here the risk is only 7.82, but in the left hand side the risk is 11.6. So, what we are learning from this risk profile picture is that when you go for taking the decision with market research study, your risk is minimized. In fact, the use of market research study lowered the probability of $9 million loss from 0.2 to 0.05. You see that previously minus 9 0.2, but now it is minus 9 only 0.05. So, the company's management would most likely view the change as the considerable reduction. Because of this market research study, there is a considerable reduction in the risk associated with the condominium project. So, it is better to go for market research study. The next agenda is finding the expected value of sample information. The right side picture shows our final result. What this result says, the expected value associated with the market research study is 15.93. The best expected value if the market research study is not undertaken, it is 14.20. Thus, we can conclude that the difference of $15.93 minus 14.20 equal to 1.73 is the expected value of sample information, EVSI. In other words, the another interpretation is conducting the market research study adds $1.73 million to the company's expected value. So, it is better to go for market research study. In general, the expected value of sample information is the difference of expected value with sample information minus expected value without sample information. So, the EVSI $1.73 million suggests the company should be willing to pay up to $1.73 million to conduct the market research study. So, this is the another interpretation of your expected value of sample information. Now, the another point which you are going to learn today is efficiency of sample information. The meaning is whether there is any worth of going for this sample information. Okay. So, that worthiness we are going to find out with the help of efficiency. So, the expected value of perfect information EVPI, in the previous lecture we have got this one $3.2 million, that is expected value of perfect information. But at present we are not thinking of perfect information because we are inferring from the sample information. So, we never anticipated that the market research report would obtain perfect information, that is not possible, but we can use an efficiency measure to express the value of market research information. So, with perfect information having an efficiency rating 100%, the efficiency rating E for sample information is computed as follows. How? Expected value of sample information upon expected value of perfect information multiplied by 100. So, 1.73, just now we got it. In the previous lecture we got expected value of perfect information 3.2. So, the ratio is 54.1%. So, what is interpretation of this 54.1%? In other words, the information from the market research study is 54.1% as efficient as perfect information, as efficient as perfect information. If low efficiency rating for sample information might lead the decision maker to look for other type of information. Suppose it is say 20, that means that what is the meaning of this 20? So, the sample information is only 20% as efficient as perfect information. So, there is no benefit of going for the sample information. However, high efficiency rating, say it is say 70, indicate that the sample information is almost as good as perfect information, and the additional sources of information would not yield substantially better result. So, many time with the help of sample information you can get the perfect information. When it is possible? Whenever the efficiency rating is high. The last agenda is the Bayes theorem. It is a very interesting concept. This idea we are going to use in our decision tree problem to find out the branch probability. Dear students, remember in our previous lecture this value of 0.94 and 0.06 and this 0.35 and 0.65, it is given to you in the problem. That means all the information about the decision tree is given to you, then we have used this backward strategy, then we found the result. In this lecture I am going to explain how we got this value of 0.94 or 0.06. So, computing branch probabilities with the Bayes theorem. Now, the company is going for market research study, we know that. So, the F is favorable market research report. So, that market research company may provide, F means favorable market research report, or they may provide U, that is unfavorable market research report. S1 represents strong demand, state of nature 1, S2 weak demand, state of nature 2. Posterior probabilities when the report is favorable. At chance node 2, please see this, at chance node 2, we need to know the branch probabilities P of F and P of U, this one P of F and P of U. At chance nodes 6, 7, 8, here 6, 7, 8, we need to know the branch probabilities What is the branch probabilities? P of S1 given F. Here it is a conditional probability. What is the interpretation of P of S1 given F? If the report is favorable, what is the probability that the demand will be strong? Similarly, P of S2F, what is the meaning? What is the probability if the demand is favorable, what is the probability of getting weaker demand? So, the P of S1 given F and P of S2 given F, this point P of S1 given F, P of S2 given F are referred to as posterior probability, because they are conditional probabilities based on the outcome of the sample information. So, this we are going to find out. At the chance node 9, 10, 11, here 9, 10, 11, we need to know the branch probability of the branch probabilities P of S1 given U and the branch probability of P of S2 given U. What is the meaning of this P of given S1 U? If the report is unfavorable, what is the probability that demand will be strong demand? That is the P of S1 given U. Similarly, if the report is unfavorable, what is the probability that the demand will be weak? Note that these are also posterior probability, denoting the probabilities of the two states of nature given that the market research report is unfavorable. Finally, at chance nodes 12, here 12, 13, 14, we need the probabilities for the states of nature P of S1, P of S2 if the market research study is not undertaken. So far I am discussing about posterior probability. Now we should know what is the prior probability. In performing the probability computations, we need to know the company's assessment of the probabilities for the two states of nature P of S1 and P of S2. So, this P of S1 and P of S2 is called prior probability. So, P of S1 given F, this is our posterior probability, or P of S2 given F, this is also posterior probability when the report is favorable. So, P of S1 given U or P of S2 given U, these are posterior probability when the market research study report is unfavorable. We have to find out these values P of S1 given F, P of S2 given F. In addition, we must know the conditional probability of the market research outcomes given each states of nature. For example, we need to know the conditional probability of favorable market research report given that the states of nature is strong demand. So, we need to know P of F given S1. We should know these values. From this, what is required for us? P of S1 given F. This is our branch probabilities, but this probability has to be known to us. What is this says that if the demand is strong demand, what is the probability this market research company will provide the favorable report? So, this probability comes from the past data of the market research company or the credibility of the result of this market research company. Note that this conditional probability of F given states of nature S1 is written as P of F given S1. To carry out the probability calculation, we will need conditional probabilities for all sample outcomes given all states of nature, that is P of F given S1, P of F given S2, P of U given S1, P of U given S2. Remember, these values related to market research study company. It is about, these values are discussing about the credibility of the report of this market research company. For example, P of given S1 may be estimated via the historical frequency of a favorable market research report in cases where the strong demand was ultimately observed. Now, the conditional probability about market research study based on historical data. So, this is given to us. What it says that when the demand is strong demand, what is the probability this market research company will provide favorable report? Say there is a 90% chance. Okay. Now, the demand is strong demand, but the company is providing unfavorable report, for that it is only 10% chance. Okay. So, another name for this one is your alpha, type 1 error. Look at the second row. When the demand is weak demand, what is the probability that the market research company will provide favorable report? That is 0.25. So, this is called your beta, that is nothing but type 2 error. So, something is weak, but the companies provide the report that it is a favorable. But look at the next one, when the demand is weak, what is the probability that market research company provide unfavorable report? So, 0.95. Since these diagonal values, right, is somewhat higher, it says that there is a reliability of the report provided by this market research company, because when there is a strong demand, 90% of the time it provide favorable report. If it is weak demand, 75% of the time this company provides unfavorable report. So, we can trust the result of this market research company. Note that the preceding probability assessment provide a reasonable degree of confidence in the market research study. How can we say there is a reasonable degree of confidence? If the true state of nature is S1, the probability of favorable market research report is 0.9. The probability of unfavorable market research report is 0.10. Look at the table. If the true states of nature is S2, that is weak demand, the probability of a favorable market research report is 0.25, this one, and the probability of an unfavorable market research report is 0.75. The reason for a 0.25 probability of a potentially misleading favorable market research report for state of nature S2 is when some potential buyers first hear about the new condominium project, their enthusiasm may lead them to overstate their real interest in it. Later, they may reverse the decision. That is why we are getting 0.25. As I told you, this is our type 2 error beta. This is your alpha, type 1 error. Dear students, I am going to recollect your knowledge on conditional probability. After that, I will explain how the Bayes theorem can be used for finding the branch probability. So, we know that P of A given B can be written as P of A intersection B divided by P of B. Suppose if I want to know P of B given A, okay. So, this can be written as P of A intersection B divided by P of A. Look at this, the numerator of this 1 and 2, numerator is same. So, what I can do, suppose in this expression, instead of this numerator A intersection B, I can write P of B given A multiplied by P of A upon P of B. So, this expression is nothing but your Bayes conditional probability. So, P of A given B is equal to P of B given A multiplied by P of A divided by P of B. If you want to represent this P of A given B in a Venn diagram, first we have to find out the intersection. Look at this, A is there, B is there. So, this shaded portion is A intersection B, that is our numerator, divided by whole P of B, okay, this P of B. So, this idea we are going to use for finding the branch probability. So, in our problem, what is given to us? Suppose I am writing. So, what we need to find out? We have to find out the probability of S1 when the report is favorable report. Similarly, we have to find out probability of S2 when the report is favorable. Similarly, we have to find out P of S1 when the report is unfavorable. Similarly, we have to find out P of S2 when the report is unfavorable. But this information is not available with us. What information is with us? We have this information P of F given S1. So, from this information we have to find out this information. What is the P of F given S1? This says the marketing research company, when the report is, when the demand is strong demand, there is a this much amount of probability that they will provide the favorable report. Here also we have this information P of U given S1. What is the meaning? This also credibility of your market research company. That is, if the actual reality is a strong demand, the probability of giving unfavorable report is P of U given S1, but we want P of S1 given U. So, this one we are going to find out with the help of the Bayes theorem. Now, dear students, in the previous slide I have explained the concept of conditional probability. Now, I am going to explain how we are going to find this branch probability by extending the conditional probability, that is nothing but your Bayes theorem. We have seen that suppose if P of S1 given F, that is what we want to know. That is, if the report is favorable, what is the probability? It is strong demand. So, what we have to do? P of F intersection S1 divided by P of F. This is our first expression. P of F given S1, this information is available with us from the report of the market research study. What is the meaning of this one? If the actual demand is strong demand, what is the probability that company will provide favorable report? So, as usual P of F given S1 divided by P of S1. So, when I cross multiply, what will happen? P of S1 given F multiply P of F equal to P of F given S1 multiplied by P of S1, that is equal to P of F intersection S1. So, from this expression, what I wanted to know? I wanted to know this information P of S1 given F. So, what I am doing? I am dividing this numerator P of F given S1 divided by this P of F. Now, I am going to pictorially represent what is the meaning of this P of f intersection S1 and the P of f. Look at the picture on the left hand side. We assume that we know the probability of favorable report. The next term says that P of S1 given f, if the report is favorable, what is the probability of strong demand? So, when you multiply this, that is the intersection P of f intersection S1. So, when the report is favorable report, there is a chance the demand may be weak demand. So, that is P of S2 given f, that is your P of f intersection S2. So, now what I can do, this P of f can be replaced by P of f given S1 plus P of f given S2. How can we replace? Because only the P of f is splitted into two branches. So, instead of P of f, we can write P of f intersection S1 plus P of f intersection S2. So, if you divide this P of f intersection S1 divided by sum of this P of f intersection S1 plus P of f intersection S2, I can get P of S1 f. But this informations P of f given S1 and P of f given S2, we are going to find out from our historical data. How? Look at this table. In this table, the prior probability is known to us S1 and S2, and P of f given S1 is 0.9. How we got this 0.9? This 0.9 we got from our this value. This value is the market research company will provide 0.9% probability if the actual demand is strong demand. That is why I written P of f given Sj, so 0.9. This 0.25 we got from this value. Okay. So, when I multiply this P of S and P of f given S1, you see that I can get P of f intersection S1, right, 0.72. But here I can, if I multiply 0.2 with the 0.25, I can get P of f intersection S2. Now, I am going to use these two values P of f intersection S1 and P of f intersection S2, I am going to substitute this value here. This expression we have seen in the previous slide. And the second one 0.05 is nothing but this one P of f intersection S2. So, in the previous slide I have shown you that P of S1 given f is nothing but P of f intersection S1 divided by sum of these intersections. So, what is that value? It is 0.2 plus 0.05. So, how we got the 0.94? That is 0.72, sum of these two values P of f, that is 0.72 plus 0.75, we are getting P of f. So, 0.72 divided by 0.77, you are getting 0.94. Here 0.05 divided by 0.77, you are getting 0.06. So, this is nothing but P of S1 given f. So, now P of f intersection S1 and P of f intersection S2, I am getting this value from our past informations. That past informations are used to find out P of S1 given f. So, this is the final value. Dear students, now I am going to summarize the procedure for finding branch probabilities with the help of this tabular approach. So, what is the step 1? In column 1, enter the states of nature, we written S1 and S2. In column 2, enter the prior probabilities for the states of nature. This information 0.8, 0.2 is given to us. In column 3, enter the conditional probabilities of favorable market research report F given each states of nature. So, 0.95, 0.9 and 0.25. Then you multiply the 0.8 multiplied by 0.9, then 0.2 multiplied by 0.25. So, this value is this is the final value. So, when you add it 0.77. To find out the posterior probability, so 0.72 upon 0.77, then 0.05 divided by 0.77, 0.94, 06. Now, we have got the final result. What is that? P of S1 given F is 0.94, P of S2 given F is 0.06. So, this value is nothing but this value. So, in our previous problem, the 0.94 is given. Similarly, 0.06 is given to you in advance. So, we have done our procedure, but now I have explained how we got this value of 0.94 and the 0.06. This is when the report is favorable. Now, the report is unfavorable, the same procedure will be followed. Now, finding the branch probabilities for the condominium project based on an unfavorable market research report. Like what you have done for our favorable market research report, same procedure has to be followed. First, you have to enter the states of nature, then prior probability. Now, conditional probability P of u given Sj. So, this portion of the data, what is the meaning of this one? When the actual demand is strong demand, what is the probability that company will provide unfavorable report? 0.10, that I have written here. When the actual demand is weak demand, what is the probability that company will provide unfavorable report? 0.75, that I have written. So, now the intersection of P of S and P of u given Sj. So, when I multiply it by 0.08, 0.15, then I have to add this. So, 0.23. So, how I got 0.35? So, 0.08 upon 0.23. So, we will be getting 0.35. Next one 0.15 upon 0.23, I am getting 0.65. Now, I got the branch probabilities of 0.35 and 0.65. Here the important concept what we are learning is, with the help of these intersections P of u intersection S1 or P of f intersection S2, we are getting our posterior probability by equating this joint probabilities. So, now we got this, I have explained you how I got 0.94, then I have explained this value also how we got 0.35 and 0.65, similarly 0.06. Now, once these values are known, then we can get the final result. So, what we have done in this lecture is that I have explained how we got the branch probabilities. In the previous lecture, this branch probability is given to you. Now, we have found this branch probabilities using Bayes theorem. Dear students, in this lecture, I have explained the risk profile. Then I have compared the risk profile of with the sample information and without sample information during decision making. The next point I have explained is expected value of sample information and what is the interpretation of this expected value of sample information. Finally, I have explained with the help of Bayes theorem how to compute the branch probabilities. Thank you very much.